this lesson, we are going to talk about the process of moving from a broad research question to a testable hypothesis, and we will touch on the intermediate levels of hypotheses along the way. So, what is a hypothesis? A hypothesis is an educated guess about the relationship between variables. Most research begins with a hypothesis and collects data to either support or refute that hypothesis. Therefore, it is important to develop a hypothesis that is testable and addresses exactly what you want to know. Ideas for research usually begin with broad research questions. For example, are dog owners happier people? Or, does eating breakfast make you smarter? Or, are people with lots of friends more empathetic? Broad research questions such as these are a great way to get an idea started, but we need to then do a little work to them to turn them into something we can test scientifically. The first step is to translate the question into a hypothesis or a statement of the expected relationship between the variables. So, looking again to our examples, we may translate the question, are dog owners happier people, into the hypothesis, dog owners are happier people. Now we have a statement of expected relationship. Let's try another one. We can restate the question, does eating breakfast make you smarter, into the hypothesis, eating breakfast makes one smarter. And finally, let's restate the question, are people with lots of friends more empathetic, into the hypothesis, people with lots of friends are more empathetic. All we needed to do in each case was to change the research question into a statement of expected outcome. These new statements are all examples of conceptual or theory-level hypotheses. These hypotheses are considered conceptual since they involve concepts such as happiness, being smart, and empathy. However, the problem with concepts in research is that we need to have some way to measure all of our variables. Concepts can be abstract and vague, making the process of testing them in a research study challenging. For example, how do you measure the concept of happiness or empathy? Happiness and empathy are typically things we don't hold a ruler to and translate into a number. However, in order to conduct research, concepts in a hypothesis need to be redefined in such a way that they are measurable. This process of making a conceptual variable more concrete is called operationalization. For example, sometimes researchers measure how well a rat has learned that a certain situation or stimulus is dangerous by measuring its fear. One way fear has been operationalized has been to measure the time in seconds that the rat freezes when presented with that stimulus. Another way this has been measured, honestly, is to count the number of droppings the rat poops while the stimulus is presented. Another reason why it is so important in research to operationalize concepts is that there can be many different ways to represent abstract concepts such as happiness or empathy. For example, one study may consider happiness to be the number of times a participant smiles during an interaction, and another study may use a questionnaire designed to measure happiness. The results of these two studies may vary greatly simply by the way in which happiness was measured. Because of this, it is very important to be very clear about exactly how a study operationalized a concept so that the results of the study can be considered in light of how the concept was measured. So, when developing a testable hypothesis, it is important to be very specific not only about how the concepts will be operationalized, but really how all variables will be measured for that matter. Once we have restated our conceptual hypothesis in measurable terms, we then have a research hypothesis. So, for example, We can turn our conceptual hypothesis of dog owners are happier people into a research hypothesis by operationalizing happiness and restating it completely in terms of how we will measure the outcome. Let's say we operationalize happiness as the score on a questionnaire designed to assess happiness. However, we are still not done because we need to specify what exactly makes dog owners happier. In other words, happier than what? When developing a research hypothesis, there will almost always be some sort of comparison involved, pitting two or more scenarios or levels of the independent variable against each other. You should always ask yourself, how will I determine whether or not my hypothesis has been supported? Let's say we are going to compare scores on the happiness questionnaire between people who own dogs and those who do not to see which group has higher scores. We can now restate our hypothesis as dog owners will have higher scores on the happiness questionnaire than those who are not dog owners. We now have a research hypothesis. Let's try another one. We had the conceptual hypothesis of eating breakfast makes one smarter. We first need to operationalize being smart. Maybe after considering this for a bit, we decide that being smart is just too broad of a concept to easily measure in a single experiment. So instead, we want to focus on memory. We may then state our hypothesis as people who eat breakfast have better memories. We may pick a word recall task as our dependent variable here and operationalize memory as the number of words recalled after a delay. Now, keep in mind that we are no longer measuring the concept of being smart. I think few would agree that a memory test really gets at the essence of being smart because there is so much more to what we consider smart to be than just memory. Memory is just one tiny component of being smart. In research, it is always best to pick more focused variables to work with than really broad ones. It happens very often that in the process of translating our broad research questions into testable hypotheses, we realize our concepts or other variables are just too broad to be effectively assessed with a single research experiment, and we may narrow these broad concepts down into more manageable ones. This is a very wise thing to do, but do be cautious that you don't then try to say in your research report that your operationalized variable is representing that original broad concept. One way to check this is to ask yourself if you think your operationalized variable adequately represents the concept you are claiming it is. For example, ask yourself, is a word recall task a good way to get at the broad concept of being smart, or is it more specific to the concept of memory? Okay, so getting back to our hypothesis, we may now restate it as participants who eat breakfast will recall more words on a word recall task than participants who don't eat breakfast. Before moving on, let's say we also suspect that the type of breakfast one eats matters. For instance, a breakfast of donuts isn't going to be as effective as a breakfast of bacon and eggs. In this case, we want to compare performance on the word recall task among participants who have bacon and eggs for breakfast, donuts for breakfast, or no breakfast at all. We could restate our research hypothesis as the type of breakfast a participant eats will affect the number of words recalled on a word recall task. Notice in this case that we didn't specify which group would do better than the others. We just said that they would be different, and that is okay. This new hypothesis is referred to as a non-directional hypothesis. By non-directional, we simply mean that the hypothesis doesn't specify the exact nature of the relationship between our variables, only that there will be one, namely that in some way the type of breakfast is going to affect how well participants do on the task. We could make it a directional hypothesis by stating it as Participants who eat a breakfast of bacon and eggs will recall more words on a word recall task than either participants who eat donuts or participants who eat no breakfast at all. So long as our hypothesis makes some sort of prediction about an expected difference, we can choose whether or not to specify the direction of that difference. The last conceptual hypothesis we need to convert into a research hypothesis is people with lots of friends are more empathetic. Let's say we decide to operationalize empathy as how accurate a participant is at judging the emotions expressed on faces and photographs. Great, but now we need to decide how we are going to decide if a participant has a lot of friends. There are many ways to do this, but let's say we decide to create two groups, those with few friends and those with many friends. And we'll make the decision to assign participants who list 0 to 5 friends that they see at least once a month in the few friends group, and those with 6 or more friends in the many friends group. We can now restate our hypothesis as participants in the many friends group will be more accurate at the emotion judging task than participants in the few friends group. Notice that we didn't specify how we broke participants into the two groups or describe the task in the hypothesis. This is okay so long as these things have been worked out and are described elsewhere in the research report. Okay, so now we know how to develop a research question into a conceptual hypothesis and a conceptual hypothesis into a research hypothesis. The last step is to now translate our research hypothesis into something we can statistically test. In experimental research, we always apply inferential statistics to our data to help us decide if our hypothesis has been supported or not. In order to do this, in addition to our research hypothesis, we need to create what is called a null hypothesis. So, the research hypothesis is always a statement of expected difference or an expected effect, that we will see a difference between two groups or that one variable will have an effect on the other. A null hypothesis is simply the statement of there being no difference or no effect. The research hypothesis and the null hypothesis are considered two types of statistical hypotheses. However, within the context of statistical hypotheses, the research hypothesis is given a different name. Usually, it is referred to as the alternative hypothesis, although sometimes you will see it called the experimental hypothesis as well. So for any experiment, we are going to have a null hypothesis and an alternative hypothesis. Let's take our first research hypothesis of dog owners will have higher scores on the happiness questionnaire than those who are not dog owners, and translate it into our two statistical hypotheses, a null hypothesis and the alternative hypothesis. The null hypothesis will be a statement of no difference between our variables of dog ownership and happiness. So, scores on the happiness questionnaire will not be different between dog owners and those who are not dog owners. Now let's state the alternative hypothesis. This will pretty much be a restatement of our research hypothesis, although because inferential statistics are always comparing the means of groups, we will restate the hypothesis with specific mention of means. Dog owners will have higher mean scores on the happiness questionnaire than those who are not dog owners. There, that wasn't too difficult. Let's do another one. Let's take our second research hypothesis and translate it into two statistical hypotheses. We'll use the version that involved the three different types of breakfast. The type of breakfast a participant eats will affect the number of words recalled on a word recall task. The null hypothesis is going to be the type of breakfast a participant eats will not affect the number of words recalled on a word recall task. The alternative hypothesis will therefore be the type of breakfast a participant eats will affect the mean number of words recalled on a word recall task. Let's now do this with our last research hypothesis. Participants in the many friends group will be more accurate at the emotion judging task than participants in the few friends group. The null hypothesis will be accuracy at the emotion judging task will not be different between participants in the many friends group and participants in the few friends group. The alternative hypothesis will be participants in the many friends group will have higher mean accuracy at the emotion judging task than participants in the few friends group. Okay, so we have narrowed our research questions down to our statistical hypotheses. Now what? Basically, with the inferential statistics we use in experimental research, we either reject or fail to reject the null hypothesis. If you can reject your null hypothesis, then it is said that you have supported your alternative hypothesis. This may seem like a strange process, but think about what happens in a court of law. The defendant is always considered innocent until found guilty beyond a reasonable doubt. In this case, the defendant's innocence is like our null hypothesis, that nothing happened. The judge or jury can either reject his innocence or fail to reject it. The defendant's innocence, or the null hypothesis, is always the default unless it can otherwise be rejected beyond a reasonable doubt. And just like in a court of law, a defendant is never really proven guilty, even though sometimes we use that term proven. Rather, the defendant is only found guilty if it is beyond a reasonable doubt. Likewise, you are never able to prove the alternative hypothesis. We are only able to reject the null hypothesis or fail to reject it. When we do reject a null hypothesis, we do so only with a certain degree of certainty, just like the beyond a reasonable doubt that is considered in a court case. Inferential statistical tests always come with p-values, which are a representation of that reasonable doubt. Basically, what the chances are that we are incorrectly rejecting the null hypothesis. We can never be 100% certain that the outcome of a statistical test is the correct one. It is always a matter of probability. So, in summary, when developing a testable hypothesis for our research study, we start with a broad research question. Next, we restate that question as a statement, a hypothesis of expected outcome. Usually this hypothesis is still at the conceptual level, so we operationalize the concepts and restate the hypothesis in measurable terms. This gives us a research hypothesis. Finally, we translate the research hypothesis as two statistical hypotheses, the null hypothesis and the alternative hypothesis. We apply statistics to determine whether the null hypothesis is rejected or not rejected. If the null hypothesis is rejected, we can say that our alternative hypothesis is supported. And that is how we go from a broad research question down to a hypothesis that is scientifically testable.